All right. So what I want to do is talk about a project that we've been engaged in at the University of Michigan that we're calling eCoach. It's an intervention tool, a way to use actionable intelligence. In order to really give an idea of what this is, I'm going to give you a little background and tell you the story of how we got there. So I'm a professor of physics and astronomy at the University of Michigan. We're a very big institution, and so this is my typical kind of classroom. 500 students sitting in front of me. And, you know, for the first 10 years that I was teaching in a classroom like this, I thought of them all as interchangeable parts. They all came to the classroom with a blank slate. You know, I should treat them the same way. Gradually, I began to get over that and to think about some of the mysteries of teaching and learning, or what, well, I think they're mostly still mysteries. What do students know when they come to the class? You know, before they even start with me, what do they know? What do they do while they're in the class? Not just in the classroom, but the whole time they're taking the class. How do they learn, and what do they remember? I started to ask questions about whether we can predict outcomes. When can we predict those outcomes? Only right before the final or before they even start the class? Can we change those outcomes? What should we do to change those outcomes? When should we do it? How should we do it? And for whom? You notice there's this for whom looming in a lot of this. It's very much about getting to each individual student. And I started to think about how we would be able to do that. It's quite clear at this conference that education systems now generate a rich stream of information about what's going on in a class, about where every student is. That rich stream of information is also becoming increasingly accessible. It's actually been there for quite a while at many of our institutions, but it's becoming increasingly accessible. Now, my own background is in big data cosmology. I've been doing this for 20 years. I ask questions about the distribution of matter on the largest scales in the universe. There are hundreds of millions of galaxies that we study. And what we do is we try to understand, how does each of these galaxies get to be the way it is? So when I turned around 5 years ago and started looking at my students in this way, I realized I could do the same thing with the students that we really do with the galaxies. And we took a group of people who traditionally had done that kind of work and started doing learning analytics work. I'm going to tell you about two different topics. The first led into the second. The first was really a learning analytics exercise, a research project called the Better Than Expected Project for introductory physics. And this project essentially generates some actionable intelligence. It taught us something about what was going on in these classes and gave us an obligation to do something about it. The second part of the talk will be about an intervention, an adaptation of public health community computer-tailored communication tools. All right, so I'm going to tell you about how we adopted tools developed in the world of public health for action in introductory physics courses. This eCoach application was grown out of analytics like this, and it is kind of in between the two talks that we've heard so far, what we might call broad analytics, which look at all students over a whole institution in all kinds of classes, and very narrow and deep analytics, like learning the multiplication table. This is somewhere in between. It has some knowledge of the general information about the student, their identity and their goals, but it also reaches into real-time, content-specific student performance data, and then tries to do something about it. So first, let me tell you about the Learning Analytics Project, something called the Better Than Expected Project. So this was an investigation into our two large year-long introductory physics courses. Many institutions have the same two courses, one of them geared towards science, physical science and engineering students, usually a calculus-based course, and a second course geared towards life science students, often an algebra-based course. We took data from our university's data warehouse for about 49,000 students over 14 years. This was largely the institutional data that resides in many of your institution's databases. Things about the students at admission, details about what they were like at the time they came to the campus, and then internal information stored about their progress through the University of Michigan up to the time when they took this class. And then inside this class, the individual exam scores and homework grades and things like that, and their final grade in this course. This is just a short summary. At many institutions, I think it's the case that a data warehouse you might have has this kind of data in it, and often much more than what you're seeing right here. So we took that information and we used it to try to construct predictions of student outcomes. We wanted to understand how well could we predict student outcomes, which features predict student outcomes, and then an important part of this project is not just to predict what outcomes we might expect to see, but also to learn who does better than expected and who does worse than expected, and then to explore why. Because we want to understand what's leading to success for students in different in different areas. The basic features of this project, the essential findings from it, are that student grades can be predicted with remarkable accuracy before they even start the term. This is a tautology, really. A student's grade point average is, by definition, the average grade they receive. And so unless the course you're talking about is utterly different from all the other courses the student has already taken, a student's GPA will make a pretty strong prediction of what grade you should expect them to get in any new class. Like I say, it's almost a tautology. There is dispersion in that, about a half a letter grade dispersion. And you can narrow that somewhat with other information. In the particular case of predicting grades in this physics course, math preparation, I guess I would say, is also relevant. And so using the SAT or ACT math scores narrows that dispersion a little, but not very much less than you might guess. There is real dispersion in this, and that's an important fact to remember. There are students who do better and worse than expected, quite a bit better and quite a bit worse. Let me show you some basic findings, and then I'll go back and tell you about performance disparities. This is kind of a way that we would display the information. So we have something that correlates with their performance, like the University of Michigan GPA at the time that they start in this class. That's what's shown on the x-axis. And then on the y-axis, we're looking at their average grade on a 4-point scale. All right? The points you see through the middle that have small error bars on them, each of those points is the median grade earned by students with that GPA in this course over this set of students. This is one of the 4 courses that I was talking about. Those medians are very well determined. That's what those error bars are, how well determined the median is. The dotted lines you see above and below demonstrate the 1 sigma dispersion at any given prediction. So there's quite a lot of dispersion in a student's performance at any given point, although we can determine these means exceedingly well because we have a lot of data in this data set. Also shown on there is a one-to-one line. If students in their introductory physics course got the same grades that they get in their other courses, they would lie on that one-to-one line. You can see that physics departments, ours at least, give out grades that are lower than is typical for other courses on campus. Okay, another thing that we discovered when we looked at this, in addition to seeing that there's real dispersion and wanting to explore it, is that there are performance disparities, particularly along lines of gender and along first generation and low socioeconomic status levels. Let me show you a little bit about that. So first, this is essentially the same figure that we just looked at, except now I'm showing it broken out for female students and male students in this introductory engineering physics course at Michigan. The set of higher points that you see that show you the medians and the errors on the mean for those medians are for male students. The lower points are for female students. This is not something that's unique to the University of Michigan. It's actually nationwide, and it's seen in a variety of courses that are like this. You can see that that gender performance disparity is pretty well across the board in terms of preparation. All kinds of students, even students who you might expect to come in at the very top level, are facing this. There are many theoretical ideas about what's responsible for this. The reason that I want to know about it is because it's present. It's a real fact in these classes. I think it is because of the environment that we've created in these classes, and we're taking steps to try and change it. Another fact that we can see is that first-generation college students underperform relative to non-first-generation college students. Again, this is not a unique thing to the University of Michigan. Here we've broken out the incoming students by ACT math score and are showing you non-first-generation students and first-gen students. Not a lot of correlation with the ACT math score, but you can see the difference between first-gen and non-first-gen students quite clearly in it. Now, what do we do about this? So what we did about it is we want to understand why people do better than expected and worse than expected. So we took students from the previous term and actually called them in for extensive structured interviews with our Center for Research on Learning and Teaching. We took the quantitative information from the learning analytics and used it to guide a qualitative study of what's going on in the class. And that's an important thing, I think, to stress, is that it's not like you only want to use numbers in doing learning analytics. There are other sources of information that are really important, and they can be really strongly enhanced by the use of qualitative things. So learning analytics like this is what made this exploration possible, even the qualitative parts. And putting it all together, we generated some kind of actionable intelligence. Okay, so when we came to the end of this project, well, it's not over. It's actually just the beginning of a larger project, I'm sure. But we now have what John Campbell calls an obligation of knowing. We know something about our students that we didn't know before. We know how we expect them to perform, and we know something about what leads to success. What we're faced with now is a question of what to do about it. How can we tailor our approaches and our interactions with students to optimize the success of all of them? We know that they're headed in different directions. We know what they need to do in order to do better than expected. We need to act on it. So there are a variety of options for intervention. One of them is to tell a person. Right? So many intervention approaches involve warning an advisor that a student is at risk, or telling an instructor that they should talk to this particular student, or telling the student themselves. Telling people remains a real challenge at many institutions because there just aren't that many people available. I don't have 700 people to act as mentors for each of these students. So the other option is to develop tools which act directly in response to the state of the student. And I can see that the Apple machine has decided to put my box in a slightly different place, but I'm sure you'll figure it out. That can be things like the intelligent tutors that we were just hearing about, that act individually with the student. They understand the content in great detail. Or it can be something like computer-tailored communication. And I'm going to talk about computer-tailored communication. This is actually a very big business, at least in the world of public health. There are a number of companies that do what's called digital health coaching. What these systems do is they provide tailored communication to people. It's seen major commercial application, and there's an extensive body of peer-reviewed research that talks about efficacy about different designs and things like that. This is used for purposes like helping people to quit smoking or to control their diabetes. There are some really interesting applications around cancer treatment decision-making, where a doctor and a patient actually sit down with a piece of software and work through all the details of their circumstances so that data can be brought to the fore at the moment when decisions are being made. So there's a lot of this out there. It turns out a very big part of it was built at the University of Michigan. So we were fortunate enough to get to work with the people who had constructed this thing called the Michigan Tailoring System. And you can see in the box up there, the Michigan Tailoring System is an open source software package created for the public health community that is for writers who want to develop tailored content designed specifically for an individual based on data known about them. All right? This is in very wide use across the public health community. It's quite a mature product. It's not something that's just at the beginning. Yep. So the MTS was built at the University of Michigan Center for Health Communications Research, and they're a real leader in doing this kind of work. What we have done is to take the learning analytics results we have and MTS to construct a project called eCoach. And you can find more details about it online, and of course feel free to ask me about it. Let me tell you basically about how it works. It's built around the core of this Michigan tailoring system. If you want to use a tailoring system like this, you need to do several things. First of all, you need to know what you would like to say to people. You need to know what you want to put in your nudges, if you like, right? We gathered expertise from a wide variety of people to do this. Then you need to have information about the students themselves. You have to flow information about the students and their current status into the system. And then the system says what you would like to say to each student. There's no artificial intelligence in this or anything. This is just a tool that enables us to say what we would like to say to each of these thousands of students. The real effort lies in understanding what you want to say and gathering the information about the students. So the way we gathered the expertise to decide what to say was to interview lots of different people. We interviewed faculty members who turned out to be much less useful than we might have imagined. And then we interviewed students. Students were more useful because they actually span the spectrum of performance. They know what different people do in order to be successful. They also have extreme relevance as testimonials for other students. So then we have to have information about the students. We did that by putting together input from the student with real-time information from gradebooks and so on. Our initial system was an opt-in system, and 54% of the students, of the 1,800 or so students in this class, opted in. What do we provide? Well, we give them tailored advice on all different aspects of the course. So what they get a website that's created specifically for them that contains a bunch of tailored communication, things that tell them how to take advantage of the different parts of the course, that give them testimonials that come from students about how they were successful in the past. And these testimonials are matched in identity and interest to themselves. So if they're a pre-med student who's really nervous about this class, they hear from a pre-med student who is really nervous about the class. They get performance feedback information about exactly where they stand in the class, and we present this to them in a variety of ways, in part so that we'll be able to to test which ways of presenting them with feedback information they find most useful. So these variety of ways is also accompanied by a survey to ask them. Now, the first term ended 4 days ago on Friday, so we don't have a lot of results to show you yet, but I can say that students who were enrolled ended up with final scores in these classes 2.3% higher, and that's a full 4 sigma difference. Although it's not a very large difference, it's very clearly detected. What I'm showing here is a bootstrap resampling of all the students who are in the class. How likely is it that you would get this result at random compared to what's actually there? All right, so we'll be looking at these effects versus usage. We'll be looking at the disparities that we've seen before, and then trying to understand what to do with this complex intervention. Let me finish up by just telling you about where I think this lives in the learning analytics landscape. There are projects like this Better Than Expected project that are analytics projects. They give us information. And computer-tailored communication is an example of an intervention engine that can be used to act on learning analytics information like that. And I'll stop there.
Questions? I think it's fascinating, this public health application.
How easily does MTS talk with the other systems on campus?
So
And how does it do that?
the way it does it is that we build a database that lives right next to MTS, and it queries from that database. So interfaces have to be made for gathering data and presenting them to this system.
Okay, so MTS needs custom design work just to go talk.
There's a framework that goes around it, that's right. The application itself for coding the messages is extremely sophisticated, quite easy for anyone to learn. That's what most of the public health researchers would use. They would say, well, I want to say it this way to these people. So that part is really easy. There's a framework around it, which is done in Django, that actually connects the database to that and then produces the message and the web content.
Can you talk about the different factors you use to tailor the communications for students? How
Sure.
segmented was it?
It's actually very segmented because we gather quite a lot of information, and then once you code some logic, it very quickly becomes the number of combinations is extremely large. So the key things that we tried to tailor on in this first round were questions of identity. So even if we're going to present the same essential material to people, we want it to come to them in a way which is effective. And the public health research shows very clearly that the identity of the person giving you the advice is very important. When Professor McKay says you have to do this, you ignore it. When your roommate says you have to do it, you pay attention, right? So we used that very heavily for that kind of tailoring. We also then tailored very much on exactly where they were and how they were doing. So if their performance was improving, we really want to recognize that. If their performance is fantastic, we want to tell them to come and work in my lab, right? I mean, really, there's a message kind of for everybody across the spectrum that way.
Can you talk a little bit about the push mechanisms, or did students have to go to the website?
So this is an issue for redesign for us, that there's a website that students go to. The way we pushed them to it was to inform them that we had updated their websites with an email and to give them some candy, kind of what it's going to look like when they go there. But usage for everybody's online systems is a very important factor, and thinking about how to integrate it. In the next term, we will be using this in a way that every student will need to go through it if they want to find out any information about their current standing in the class. So that's a pretty strong inducement.
I'm afraid we're going to have to move on to the next speaker, so hopefully you'll be around this evening.
I will be around this evening.